Okay, now let's introduce a new way to compute the area of parallelogram or the volume of box. Okay, so the area of parallelogram is equals to the absolute value of determinant of A, where this A is A, B, C, D, and A, B, C, D are two sides of parallelogram. Okay, and the volume of the box is also the absolute value of determinant A. If the rows of A gave the size of the box. Okay, so the rows actually is the size of the box. So each row is the set of box here. And here we give you examples here. If a box has side A, B, C, D, F, G, H, I, so there are three sides here. Okay, and be careful that you have to choose three linearly independent vector sides. You can't choose the parallel sides. If you choose the parallel sides, you will get 0 here. Okay, then the volume equals to absolute value determinant A, B, C, D, E, F. This is the first side. This is the second side. This is the third side. So this is how we use determinant to compute the volume of a box. Okay, and here we introduce the new definitions here. It's called cross product. The definition of cross product is it is a vector. Okay, be careful with this. It's a vector, not a scalar. The dot product is a scalar, but the cross product is a vector. Okay, this is a vector with length, the length of u times length of v times the absolute value of sine theta. Here the theta is the angle between u and v, and its direction is perpendicular to u and v, and it points up or down by the right hand rule. Okay, so let's see. So if this is u and this is v, okay, then we know that this the direction of u of cross product v points along your right thumb when the fingers curl from u to v. Okay, when your fingers curl from u to v, and the direction points along your right thumb. Okay, so this is this direction. Okay, so this direction is perpendicular to u and v. Okay, and this is u and v, and the length is this number. Okay, okay. Be careful. You can only use your right hand. Okay, this is why it is called right hand rule. Okay, and if we have formulas here. If you have the coordinate of u and have the coordinate of v, then you can get the coordinate of u cross product v by this formula. Okay, this is ijk. This is determinant of ijk, u1, u2, u3, v1, v2, v3, and you can expand this determinant by the first rule. Then we get the I vector I times the cofactor C11. So C11 is remove the first row and first column, so it is U2, U3, V2, V3. So it is U2 times V3 minus U3 times V2 plus the J times cofactor C12 plus K times cofactor C13. Okay, and we also know that the I is 100 and J is 010 and K is 001. So the coordinate of U cross product V is U2 V3 U minus U3 V2. This is the first component. The second component is U3 V1 minus U1 V3. Okay. The third is U1 V2 minus U2 V1. Okay. And here is the triple product formula. U cross product V and dot product W equal to determinant U1 U2 U3 V1 V2 V3 W1 W2 W3. Okay. So this is to remember this formula. It will help you solve the problem 34 here. Okay. So let's first solve this problem. So which of the triple products U cross product W times V dot product V and W cross U dot V and V cross W dot U are the same as U cross V dot W? Okay, so let's see their corresponding determinant by this formula. Okay, this formula gives you a corresponding determinant with this triple product. So first let's see WUV. So W cross U dot V is determinant WUV, right? You just list these three vectors as the row of this matrix. Okay, and the determinant, then we can change the row 1 and row 2. Then we get the minus 1 times determinant UWV here. Okay, so every time you exchange two rows, you have 2 times minus 1 here. Okay, and then we exchange row 2 and row 3, we get UVW. Okay, and there's another minus 1 here. So it is minus 1 to the power 2, so it's 1, so it is equal to determinant UVW equals, so we know that, we know this is equal to U cross V dot W. Okay, so we get this result, W cross U dot V equals U cross V dot W. Okay. Next, let's check the V cross W dot U. It's equals to determinant VWU. The order is V is the first, W is the second, U is third, so you list these 3 rows here. So VWU, and then we can exchange the row 1 and row 3. We get UWV, and we have 2 times minus 1 here. And then we exchange row 2 and row 3. We get UVW. Then we need to multiply another minus 1 here, so it is minus 1 to the power 2 times determinant UVW. It equals to determinant UVW equals U cross V dot W. Okay, so we get V cross W dot U equals U cross V dot W. Okay. these two triple product equal to each other. Okay. Let's see, last one. So U cross W dot V, okay, equal to determinant U. Okay, U is the first one, W second, V third, so U W V. Then we change second and exchange second row and third row. We get -1 times determinant UVW. Okay, so it is -1 times U cross V dot W. This not equal to U cross V dot W. Okay, there's a -1 here. Okay, so the last one not equal to U cross V dot W. Okay, only the first two equals to U cross V dot W. Okay, this is not equal to. Okay, so here we find that we only use one permutations here. We use two permutations here, and we use two permutations here. Okay, this is two permutation, and this is two permutation. There is only one permutations here. Okay, so we get these conclusions here. Even permutations of UVW keeps the same determinant. All the permutations like UWV will reverse the sign. Okay, UWV, you only use one permutation here, will get the negative sign here. Okay, we'll reserve the sign. Okay, this is problem 34. And let's see problem 16. Find the area of the parallelogram with edges V equals 3, 2 and W equals 1, 4. Okay, so we can directly use the area of parallelogram, list these two edges as rows of the matrix A. So it's 3, 2, 1, 4, and take the determinant, then take the absolute value. So it is 3 times 4 minus 2 times 1. Okay. So it's 12 minus 2, so we get 10 here. Okay. Next, you need to compute the triangular area formed by the W, V, and V plus W. Okay, so which means this area, the area of this triangle. So we know that this triangle area is equal to 1 over 2 times area of parallelogram. So it is 1 over 2 times 10 equals 5. Okay. You can also use the area of triangle formula in the page 276. You will get the same result. Okay. Actually, the formula in this page is equivalent to this. Is similar. Is the same formula with this one, with this parallelogram. You only need to times 1 over 2, then you will get the area of triangle. Okay. And next is to find the area of triangular formed by W, V, and W minus V. So this is W minus V, this side. Okay. And this area is also equal to half of the area of parallelogram, so it is 1 over 2 times 10, so it's 5. Okay. Let's see the last problem 19. So the parallelogram with sides 2, 1 and 2, 3 has the same area as the parallelogram with the sides 2, 2 and 1, 3. Explain why they must equal. Okay, so we list their area. So their area equals to determinant. So the first row, first side is 2, 1, second side is 2, 3. So it is 2, 1, 2, 3. Take the determinant, then take the absolute value. So this is, and we let this matrix to be A. So this is determinant A. And the second parallelogram is with sides 2, 2, 1, 3. So we list the first row to be 2, 2 and the second row to be 1, 3. So this is then take the determinant, then take the absolute value. Okay, and we can find the relationship between this matrix and this matrix. Okay, so if this is A, this should be A transpose. So this is equals to determinant A transpose, then take the absolute value. Okay. So why these two areas is the same area, is equal? It's because determinant A equals determinant A transpose. Okay. So this is why they must equal. Transpose has the same determinant. Okay, that's it.